Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we have discussed the summary of the one of the molecule, that is ribosines A and B, and that the enzymatic synthesis of minus ribosine A and B using dibenzobidifurans, that is the title of that paper, and the molecule is a minus ribosine A and B. And in that, only the notable point we described there is no formation of new carbon-carbon bond taking place. Whatever the molecule we have studied so far, that molecule ribosine A and B is exceptional, where there is no new carbon-carbon bond formation or breaking occur in that synthesis. That is a noticeable and the most important or the significant point we have discussed over there, and the rest of the thing, how 9 step is required, what is the starting material for it, how the stereochemistry are maintained, and then how they done the characterization, how they prove, and from where it is extracted, in which plant that molecule contain, or so that type of the description we already discussed in our previous lecture. So today we are going to start the molecule which is the last molecule of the section. First course number we are studying or learning CCTP, or previously known as a CHO-450, the chemistry of natural product. And in that first section, this is the last molecule, and this last molecule is generally kept for the self-learning. Means student, you have to learn on your own, but let's see how you can learn this molecule. So that's I am trying to explain this molecule also in detail. So this is also as one of the paper which is published in GOC. GOC, as we know, that Journal of Organic Chemistry, which is a very well reputed organic journal, so having very high impact factor. So the reason behind it, students should acquire the knowledge of representing, how to write the papers, what kind of the research you can carry on your own, that type of the self confidence you can build on you. So that is the main purpose of introducing such type of the molecule on your self learning. So that is the objective of the syllabus introduced by the Savitribai Phule Pune University, Pune, from July 2020. So here today the Subincanadine E, we are going to see what could be the structure of there. Before that, so this Subincanadine E, self-learning, means you have to learn on your own. Journal of Organic Chemistry, published in 2017, and volume number is 87, page number also given 11,126 to 11,133, near about 7 to 8 pages are there, and title of this paper is the total synthesis of plus minus or plus Subincanadine E and determination of absolute configuration. So see the determination of absolute configuration. So far we are hearing the word absolute configuration, but how that is included in the title of the paper means main focus toward the stereochemistry, because that is stereochemistry plays an important role in deciding what kind of the property that molecule has, because minor changes in the configuration of that organic compound, it can changes all the property, and that's why the absolute configuration is a very essential as far as medicinal point of view is concerned. Because if the configuration, because just we know that the isomer means having as the same molecular formula, but different structure are known as a isomer, but there are the different categories are there. Isomers are isomerism further divided into as a two type that we already discussed in our previous classes, even though from starting from 11th standard to still M.Sc you are learning that stereochemistry, because and in that let me give just a brief idea regarding that. There are broad two types are there. One is called as a structural isomer and another one is called as a stereoisomerism. Structural isomerism is depending upon the structure, the connectivity of that carbon-carbon connectivity or the skeleton, that type of the compound, that type of the isomer are generally termed as a structural isomerism, and stereoisomerism means the arrangement of the atom specifically in the space, that orientation of atom in the space. So that type of the study of that molecule in 3D, where you can observe orientation of the atom in a space, how they are connectivity of that atom, orientation of that atom. So that type of the thing are called as stereoisomerism. And here structural isomerism again further divided into as a 5 types, like as a chain isomerism, position isomerism, functional group isomerism, tautomerism, metamerism. So that type of the different with the their example also we do that, but here we are not going to discuss, only the brief idea we are taking. And then after that the stereoisomerism further divided into 2 types. One is called as a optical conformational isomerism and the configurational isomerism. Conformational isomerism means just by rotating as a carbon-carbon single bond, we will get as a different type of the isomer, like as a staggered isomers and the eclipse isomer if the compounds are open chain. So that type of the isomerism is known as a conformational isomerism. Just rotating as a carbon-carbon single bond, we are getting as a different type of the isomers, like as a eclipse conformation, staggered conformation, partial eclipse conformation, fully eclipse conformation. So that type of the conformation you already. And then after that there is a configurational isomerism. Configurational isomerism means the restriction of that rotation of the carbon-carbon double bond is a rotation of the carbon-carbon double bond is restricted due to the presence of carbon-carbon double bond, and the isomer gives rise to octane is known as a configurational isomerism. Again it is further divided into as a 2 types. One is optical isomer, another one is a geometrical isomer. geometrical isomer, we know that in terms of, again further divided into two types, cis and trans. Cis means a similar group are on the same side of the carbon-carbon double bond is termed as a cis isomer, whereas a trans isomer, the similar group are on the opposite side of the carbon-carbon double bond, that is termed as a trans isomer. Trans isomers are generally more stable than the cis isomer. The reason is very clearly, if you observe the two structure carefully after driving that two structure on in your notebook, you will clearly find there both the methyl group. For example, if you taken as a simplest example is a 2-butane. 2-butane has a two geometrical isomers, cis and the trans, and if you observe that two structure very closely, you will find both the methyl group are well separated from each other. There is no steric entrance, and therefore they are more stable. But in the other hand, if you observe the structure of cis-2-butane, there you will find both the methyl group are nearer to each other. They create a lot of steric hindrance or lot of steric crowding is there, and due to that steric hindrance or crowding, the internal energy increases. And once the internal energy increases, there is one general rule for the stability of the organic compound. Those organic compounds are about the reactivity. Those organic compounds having as a more energy, they are the less stable one, and therefore here the potential energy increases, the stability of that molecule means cis molecule is less as compared to as that type of thing. And then optical isomer. And optical isomers, it is one of the, there you have to measure the optical activity of that certain molecules, because the most of the natural compounds possess optical activity because they are having a chiral center. Chiral center means the carbon atom carrying as a 4 different group is known as a chiral center or stereogenic center, and they that type of the compound possess very important property, that is a optical. They shows as a optical rotation either clockwise manner or anti-clockwise manner, depending upon how the atoms are orient in a space. Depending upon that, they are exhibiting the optical rotation, and the instrument is used to determine the optical rotation of that molecule or the compound. The name of that instrument is a polarimeter. Polarimeter used to determine the optical rotation of that organic compound, and during that process, theoretically we can easily find out whether it can rotate that compound either left hand side or the right hand side, levorotatory or the dextrorotatory, if only one chiral center is present, and then there the terms are coming as a enantiomer, diastereomers, epimers, then hanomers, that type of the word you might have heard during that process. So in absolute configuration means R and S. There are relative configuration and the absolute configuration. Generally, the molecules are written on the blackboard or in the book, the organic molecule according to as a Fisher projection formula. And there are the certain route how to represent the organic molecule according to as a Fisher projection formula, and then find out give the priority numbers. There are total 4 priority numbers, and that priority numbers are depending upon how the priority numbers are given to that atom. The priority numbers are given according to as a sequence rule, and you know that the sequence rule means what? Arrangement of atom or arrangement of group around the chiral center is known as a sequence rule, and that sequence rule is formulated or given by the 3 scientists, which is also known as a CIP rule, and that's according to CIP means Kahn, Ingold, Prelog. These 3 scientists together work together and they formulated one of the very important rule, and that rule has 1, 2, 3, 4, 5 type of the rules are there. Number 1, depending upon the atomic number. Second one is the next atom. Third one is a double bond or triple bond, and fourth one is a isotope. These are the rule, and those are knowing those rule, and then give the priority numbers 1, 2, 3, 4, and then travel from 1, 2, 3, and then see whether that traveling that motion, whether it is a clockwise or a anti-clockwise. If it is a clockwise, then see where the 4th priority group. If it is at the top or what we can call it as the bottom, then there is no change in the configuration, it remains as it is. But if it is present horizontally, then the configuration should be inverted, inversion of configuration. Suppose as a motion is a clockwise, then your configuration must be the S configuration. So S stand for sinister and R for rectus. So these are the foreign word or the languages. So that sinister means left-handed. So that type of absolute configuration. R and S are known as absolute configuration, and capital D and capital L, capital D and capital L are termed as relative configurations. Relative configuration, they are the just referred in case of the amino acid, while studying as amino acid and the carbohydrate chemistry. And in a carbohydrate chemistry, generally OH, hydroxy group from the bottom, if at 2 position hydroxy group are on the right hand side, then it is termed as a D configuration. If it is present on left hand side, then it is termed as a capital L configuration. So that are the relative configuration, but absolute configuration are the different. They are absolutely depending upon that. So that absolute configuration is nicely studied in this paper, and by the 2 scientists. The name of the 2 author or 2 scientists, Manoj Kumar G. Kalsetti, Manoj Kumar G. Kalsetti, and the corresponding author is Narasimha P. Argade. So these 2 scientists that are the Indian researcher, Division of Organic Chemistry, National Chemical Laboratory, you know that. National Chemical Laboratory, where it is in Pune, also there. It is a National Chemical Laboratory, CSIR. CSIR means what? Council of Scientific Industrial Research. So that is a full form of that CSIR, because in the National Chemical Laboratory there are the different divisions are there, and there continuously they are working they are trying to find out the new invention, new methodology, designing the processes, or they are finding new and new organic molecules, and they are trying to screen them, finding their biological activity, or so that type of the collaboration. Once they are setting that processes and they giving to the industries, because the funding which are coming for their salary or other purposes, all are providing by the industries, and therefore they are trying to improve the process designing or the new development, new researchers are daily going on in that laboratory, and therefore it is known as a National Chemical Laboratory. One is situated in Pune at Pashan, that is run by CSIR. CSIR, full form of CSIR will be the Council of Scientific Industrial Research. So that is there. And now the title of the paper just now we have seen, total synthesis of plus minus or plus Subincanadine E and determination of absolute configuration. So the abstract and how the important points are there. A fossil synthesis of plus Subincanadine E. Subincanadine E was described from tryptamine based maleimide. Tryptamine based maleimide. 1,2 addition of Grignard's reagent, as we know that Grignard's reagent, which is the simplest reagent which we can prepare easily in the laboratory. So that 1,2 and it can be Grignard's addition can be occur 1,2 toward the carbonyl group and or 1,4 if there is a alpha beta unsaturated compounds are present. So there are two types, 1,2 addition of Grignard's reagent. And do you know what is Grignard's reagent? Grignard's reagent is nothing but as a RMGX. This is a general formula of Grignard's reagent. It is a organometallic compound because here the magnesium metal attached to that carbon atom, and therefore it is organometallic compound. And how do you prepare Grignard's reagent? It's a very simple process. The starting material required for it alkyl halide. RX is known as alkyl halide, and it will be treated with the pure magnesium metal, and the solvent used as a dry ether. Why dry ether? If there is a drop of water present over there during that formation of the Grignard's reagent, during that synthesis or during that preparation, it may cause as a fire. It can catch the fire, and to avoid such accident, the ether used as a solvent, very dry in nature, and then the resulting compound form is called as RMGX. So that Grignard's reagent. Now what is the speciality of that Grignard's reagent? He awarded by the Nobel Prize for this simplest reaction, but a very, very important one. If you see the nature of that alkyl group, where RX, because RX it is a polar compound. Polarity is developed. Polarity means there is a charge separation, and as we know that halogen family member has great ability, great power to attract the electron density toward, and therefore there is a partial negative charge developed on that halogen atom and partial positive charge developed on that carbocation. And if you see the organic compound, most of the organic compound containing, I think more than 75% organic compound containing as a carbonyl group, and therefore, and if you see the carbonyl group, carbonyl carbon, it has the positive charge, means it is electropositive in nature. Whenever you are going to add as alkyl halide, there is no reaction, because even though carbonyl carbon is a reactive, no doubt about it, but as we know that positive or negative, they repel to each other. There is no formation of the bond takes place, and therefore the carbon, if there is no formation of the new carbon bond, then there will be no new organic compound will not form. And therefore, what the Grignard did, he inserted as a magnesium metal and form as a bond between carbon and the magnesium. When such a type of the things are happen, the R group, alkyl group is change its polarity, and as we know that metal always carries as a positive charge, and ultimately the carbon atom, when Grignard's reagent is formed, it carries as a minus delta charge, and therefore Grignard's reagent has nucleophilic addition toward the carbonyl group, and we can make the new carbon-carbon bond formation, and that is a new invention, and therefore its Grignard's reagent is a very important organometallic. We can make the new carbon-carbon bond formation process, and therefore it is very good for the discovery of the new, because he totally changed the nature of that R group, and that's why he awarded by the Nobel Prize. By using that Grignard's reagent, we can synthesize, we can make the millions of organic compound, billionth of organic compound by using this reagent, and that's why it is a versatile reagent. Variety of the organic compound we can prepare from this. And here also they use that Grignard's reagent. One to addition of Grignard's reagent to maleimide internal activation of formed lactomal foreign situ. Situ, as we know that it is one of the container, we can call it, where the reactions are generally carrying out. In organic chemistry, most of the reaction intermediate are produced in situ, as in reaction mixture, because they can be unstable or may be toxic. 1,4 addition of Grignard's reagent and associated position specific allelic rearrangement, and as we know that allelic rearrangement in distereoselective Pictet-Spenger cyclization were the key steps. These two words they are highlighting, they are saying these are the two words are the key word. One is a allelic rearrangement and another one is a Pictet-Spenger cyclization. And enantioselective, as we know that enantioselective, when you can use this enantiomer you might be remember as a general organic compound used for that is a glyceraldehyde. Glyceraldehyde CHO, then middle carbon having as a OH on the right hand side and H on the left hand side, and below is a methyl group. If you observe that glyceraldehyde, that is a general arrangement or representation of that glyceraldehyde, and put the mirror there, and once you put the mirror you can see its mirror image, right? Now let's see, these two hands are the good example of the enantiomer. These two hand, our two hand are enantiomers of each other. Means everything is the same, but there are rotation. One is rotating the plane of polarization right hand side, where another rotating as a plane of polarization, means they are the non-superimposable mirror images. They are not the superimposable, they are non. This word is very essential, very prominent while defining as a enantiomer. Enantiomer means what? They are non-superimposable mirror images are known as a enantiomers. So that enantioselective first total synthesis of naturally occurring cytotoxic, as we know that this is a very important word. Why we are studying the Subincanadine? Because it shows the cytotoxic. If you see the word cyto means cell. In the botany you might word, and toxic, we know that it is a poisonous, that type of the substances. So it is a cyto means cell killing. So whenever there is a diseases are there, like as a cancer, so there the uncontrolled cells are developed, and to kill the cells, so that type of the word generally used as a cytotoxic, and that cytotoxic toxic to cells. Cytotoxic means toxic to cell, or cell toxic, cell killings, any agent or process that kills the cells. And chemotherapy and radiotherapy are forms of cytotoxic therapy, and they kill cells. The prefix cyto denotes a cell, or cytotoxic refer to a substance or process which results in cell damage or cell death. The doctor found vitamin C had a cytotoxic effect on cancer cells and reduced their numbers. These are some of the terms. So why we are studying the Subincanadine E, the reason behind it shows or it exhibits cytotoxic biological activity. And plus Subincanadine E was also accomplished from S-acetoxy-succinamide via an unusual syn addition of cuprate to the alpha beta unsaturated lactam. Sinister means yes, absolute configuration was assigned to plus Subincanadine E on the basis of total synthesis. So let me give that the structure of Subincanadine E plus minus Subincanadine E, the structure is this one. So if you observe the structure of Subincanadine plus minus Subincanadine, you will find here, this is a structure which I am drawing here. Let's see, and then there will be here N, then we can show here this is the bond which attacking over there, then here double bond this, and then this is the bond which is attacking over there, and there will be a hydrogen atom should be below the plane, and here must be the double bond. If you observe this structure carefully, this is a structure of Subincanadine, is a plus minus Subincanadine E. This is a structure of Subincanadine E. Observe this structure very carefully. Look at, this is one of the moiety, indole moiety, as we know that, indole. In a previous we have seen as a benzofuran moiety. Here is a indole moiety. One is a 6-membered ring benzene fused with the 5-membered heterocyclic compound, that is a pyrrole, and the resulting compound form is called as a indole. This is a indole moiety, and look at here, some rings are there. So that is a bigger ring, 1, 2, 3, 4, 5, 6, 7, 8, 9-membered ring over here, and here 1, 2, 3, 4, 5 and 6-membered ring once again. 1, 2, 3, 4, 5 and 6 membered ring. This is also has a 6 membered ring, and this one is a 5 membered ring. So there are how many number of rings are present? So here you can see 1, 2, 3 and 4 rings are total. 4 rings are there if you observe this structure carefully. Another thing, the aromatic. This is a aromatic compound, or this is a indole moiety. Now this is a big ring, and this is again as a 6 membered ring. 2 are the 6 membered ring, 1 5 membered ring, and 1 is a big, that is a 9 membered ring. And what are the functional groups you can observe over there? Look at here, carbon carbon double bond, here also has a carbon carbon double bond. The nitrogen, that is it can act as an basic property, right? Because that is a tertiary amine is also as a one of the functional group is present over here. And now see there, olefinic carbon carbon double bond. How many chiral? Main important point over here, because we are in the heading, the author are trying to, the scientists are trying to prove the determination of absolute configuration. Determination of absolute configuration, only one chiral is present in the compound, and now only one chiral where see only here one chiral center is present over there, and therefore this compound, what do you think, whether it is optically active in nature or whether it is optically active or optically inactive? It is optically active in nature, because only one chiral center is there, and therefore it is very easy to find out its optical activity. Now whether this chiral center has R configuration or S configuration, what do you think? So for that we have to assign, we have to give the priority numbers 1, 2, 3, 4, and then see the motion of that arrow, whether it is a clockwise manner or anti-clockwise manner, by following as a CIP rule, and then you can clearly find out whether it is a R configuration or the S configuration. That is a promising challenge for this over here. So I think this is a general information, introductory information I have provided you. I think with this, in the next lecture we are going to find out what will be the configuration of this at this chiral center, whether it is a R configuration or S configuration, on the basis of sequence rule. And I think with this, let us stop today here. Thank you. Have a nice day.